Here's the last problem on the first derivatives test that's very common on the AP exams and on the calculator section. And so what they'll often do is they'll just give you a function's derivative, and then they'll ask you to find relative maxes or mins. So you'll need your calculator for this problem. They're telling us that f prime of x is equal to x cubed. So you're going to want to take out your calculator and actually plug that in. Okay, so take that out and make sure you're in radian mode. Type cosine of x cubed Okay, and then when you're done with that, go adjust your window and make your x min 0 and your x max 2.1. And then you're taking the cosine of something, so that's never going to be more than 1 or less than -1. So maybe make your y min and max -2 to 2, just so we can get it, make sure we can accommodate the whole graph. And then you hit graph. So it's on the screen there, but I'm just going to make a sketch of this function. And the important thing to remember is this is a function. This is a graph of the derivative, not the function itself. So I'm just going to say this is f prime, and it looks like it's doing something like this. On the interval we care about, it's doing something like that. Okay, so here's where you're going to want to make sure you understand what you're looking for. This is the derivative. If we want a relative min, we want to know when does f prime change from negative to positive, right? From negative to positive. That's where a relative min would occur. And seeing as this is the graph of the derivative, that means we're going to want to find this point, right? The derivative is positive, so the derivative is positive. F prime is positive. Here f prime is negative. Here f prime is positive, and here f prime is negative. So we only care about the moment it changes from negative to positive. That defines a relative min. Notice we don't have to check the endpoint 2.1 because even though the derivative is negative there, because it's given us the open intervals, so we don't have to check the endpoint. So the only instance on this interval here where the derivative changes from negative to positive is right there. So you're going to want to use your calculator to find the 0. And if you do that, you get, it happens at negative, this is happening at negative 1.676, or 677, I guess, technically, if we round correctly. So we answered the question there too. That is the x value at which this function attains a relative minimum.